Now, afterward in this lecture, we have to see the properties of nickel tetracarbonyl. This topic is in physical plus inorganic chemistry paper. This unit, metal carbonyls. We have seen what are metal carbonyls. We have seen their classification, and for your syllabus there is preparation, properties, and structure of nickel tetracarbonyl. We have seen the preparation of nickel tetracarbonyl. Now we have to see what are the properties of nickel tetracarbonyl. So first, physical properties. This nickel tetracarbonyl is a colorless liquid at room temperature. The melting point of nickel tetracarbonyl is minus 23 degrees Celsius and boiling point is 43 degrees Celsius. So at room temperature it is in liquid state. This it is soluble in organic solvents but insoluble in water. So these are its physical properties, its melting point, boiling point, solubility and color. Now we have to see its chemical properties. First, action of heat. I have shown all the properties in one slide. I will explain one by one. This one, you are getting the cursor. You are able to see the cursor.
Yes, sir.
Okay. So this is, I have shown here this triangle delta. It is for heat. So what is the action of heat on nickel tetracarbonyl? When nickel tetracarbonyl it is heated up to 100 to 180 degrees Celsius, this nickel tetracarbonyl decomposes in nickel and carbon monoxides. Okay. Then what is the reaction of HCl, hydrochloric acid? Hydrochloric acid in gaseous state. When hydrochloric acid reacts with nickel tetracarbonyl in a gaseous state, we have used that hydrochloric acid, that is the solution of hydrochloric acid, hydrogen chloride. Okay. So when HCl reacts with nickel tetracarbonyl, all the four carbonyl groups gets replaced by Cl2 and we get nickel chloride salt. So this is another one reaction of nickel tetracarbonyl. And when it is reacted with H2SO4, third reaction, reaction of nickel tetracarbonyl with H2SO4, same reaction when it reacts with H2SO4, we get nickel sulfate. It is a salt. Nickel sulfate is a salt, just like nickel chloride, it is also a salt. We get nickel sulfate when reaction with H2SO4, then the hydrogen gas and 4 carbon monoxide molecule. This is third reaction. Fourth reaction, when it reacts with halogen. For example, I have taken here chlorine. When nickel tetracarbonyl reacts with chlorine, we get nickel chloride plus 4CO. Okay. Then the reaction with barium hydroxide, we get hydride nickel carbonyl, tricarbonyl. So the one carbonyl group gets replaced by that H2 and we get the barium oxide. Okay. So these are the reactions with barium hydroxide. Then the nitrogen oxide reaction with nitrogen oxide. When nickel tetracarbonyl reacts with nitrogen oxide, aqueous nitrogen oxide, we get nitrosyl hydroxide, this complex. We get this complex plus carbon monoxide and hydrogen. Then the another reaction is the reaction with nitrogen oxide gas, anhydrous. It is with water, nitrogen oxide and water. It is pure nitrogen oxide without water. We get the then this type of complex we have obtained nitrogen dioxide and nitrogen oxide nickel complex plus 4CO and nitrous oxide. Then it is the reaction with CNR. This CNR is also a ligand, carbonyl is also a ligand. So when reacts with nickel tetracarbonyl reacts with CNR, we get this type of complex. All four carbonyl ligands gets replaced by this CNR ligand and we get such type of complex. Similarly, PCl3 is also a ligand. So PCl3, that four carbonyls gets replaced by PCl3. Then it is nitrogen dioxide. We get nickel nitrite. We get nickel nitrite. So all these are the reactions of nickel tetracarbonyl with various reagents in this. In this one slide, we have completed 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 reactions. So such type of notes, when we call notes, then the notes should be of such type. All these 10 reactions will be covered in half page of your notebook. तुमच्या अर्ध्या वहीच्या पेजमध्ये या सगळ्या नोट हे सगळं बसते. ओके, येतोय आवाज क्लिअर?
हो सर.
ओके, बाकीचे कोणी दिसणार चालले? ओके ओके. सो these are the notes. बस ह्याच्यामध्ये एवढं आहे की तुम्हाला ह्या रिॲक्शन वरून एक 2-3 लाईन्स लिहिता आल्या पाहिजेत. 2-3 लाईन्स कसा, समजा रिॲक्शन ऑफ निकेल टेट्राकार्बोनिल विथ हीट. ओके, so action of heat, nickel tetracarbonyl when heated up to 100 to 180 degrees Celsius, then it decomposes. That sentence you may able to write. Okay, then it decomposes into nickel and carbonyl. Similarly, when hydrochloric acid gaseous state reacts with nickel tetracarbonyl, we get nickel chloride salt plus H2 plus C4CO. Just products are same, just like I have not written here. Then the action of H2SO4, same sentence you have to write. Nickel tetracarbonyl reacts with H2SO4 and we get nickel sulfate salt plus hydrogen and carbon monoxide. Similarly, here also nickel tetracarbonyl reacts with chlorine. The four carbonyls gets replaced by Cl2. We get nickel chloride and 4CO. Just like you have to write the sentences, only for remembering you have to remember this one page only. So all the properties of nickel tetrachlorides will be covered in this one. I will provide you the detailed notes. So this is regarding the properties of nickel tetracarbonyl. Now we have to see its structure of nickel tetracarbonyl. Now, how to predict the structure? There are some physical methods to predict the structure, to determine the structure, like X-ray diffraction studies, IR studies, NMR studies. So the molecular formula of this nickel tetracarbonyl is determined by vapor density and depression in freezing point. These are the two methods to determine the molecular formula of this complex. Okay, so the molecular formula is obtained as NiCO 4 times, means there are 4 carbonyl ligands and 1 nickel atom. Now the electron diffraction measurements and X-ray diffraction studies shows that there are 4 linear NiCO units. The arrangement of these 3 atoms, nickel, carbon and oxygen, is linear, and such linear atoms are the linear units are 4 linear units are there in the structure of nickel tetracarbonyl. So we may write the structure of nickel tetracarbonyl as this one. At this point we don't know what is the geometry. Geometry may be tetrahedral, maybe square planar, or maybe other. Okay, आता ह्या पॉइंटला आपल्याला जिओमेट्री माहिती नाहीये, फक्त काय माहिती आपल्याला, मॉलिक्युलर फॉर्म्युला NiCO4 times. This is the molecular formula, and there are 4 NiCO linear units. Just in this structure letter, this is NiCO 1 linear unit, NiCO, this is NiCO, this is NiCO. Okay. Now the nickel carbon bond length is of 1.15 angstrom. This nickel carbon bond length is 1.15 angstrom, and carbon oxygen bond length is 1.50 angstrom. These are the bond lengths. Now we will see the orbital diagrams. Now this nickel tetracarbonyl, its vapor density, from vapor density studies and diffraction in freezing points, we have determined molecular formula, X-ray diffraction. From that, we have determined what are the units, linear units. Now, when the magnetic properties of this complex is studied, then it is found to be diamagnetic. Nickel tetracarbonyl is diamagnetic. What it means? If a compound is diamagnetic, then there are no unpaired electrons. We have studied last year in d block elements. Then if there are unpaired electrons, then the compound is paramagnetic. But this nickel tetracarbonyl is the diamagnetic, that indicates there are no any unpaired electrons. Okay. Now we will see the orbital diagrams, what type of hybridization should be there. So what is the atomic number of nickel? Tell me someone.
28.
28. Its electronic configuration, you are seeing on your screen. Electronic configuration of nickel atom in ground state is 3d8, 4s2 and 4p0. Okay. There are 8 electrons in 3d orbital and 2 electrons in 4s orbital, whereas 4p orbital is empty. It is in ground state. Now, when it undergoes hybridization, when it undergoes hybridization, then we may say that it is nickel is in zero oxidation state in nickel tetracarbonyl. In any carbonyls, the metal atom, metal ion may be in zero oxidation state or the lowest possible oxidation state. Okay. Here in nickel tetracarbonyl, this nickel is in zero oxidation state. So in a excited state also, these two electrons will not be removed. हे दोन इलेक्ट्रॉन 4s मधले रिमूव्ह करत नाही. आपण जनरली कसं करतो, कॉम्प्लेक्सचं बघताना nickel plus 2 electrons from 4s gets removed and remaining there is hybridization likewise. But here nickel is in zero oxidation state. Okay. So during hybridization, these two electrons from 4s orbital shifts to 3d. These two electrons shifts to 3d orbital. Now in this configuration, you see this configuration, nickel, all electrons are paired in d orbital. The electronic configuration is 3d, 3d10. All electrons are paired. And the 4s orbital and 4p orbital is empty. So this nickel atom undergoes sp3 hybridization. This sp3 hybridization. This undergoes sp3 hybridization. Then the field orbital of carbonyl ligands overlaps with these four empty sp3 hybrid orbitals. Now the hybridization is sp3, so the geometry must be tetrahedral. So the geometry of nickel tetracarbonyl is tetrahedral. It is tetrahedral in geometry. Hybridization is sp3. All electrons are paired in 3d orbital. That's why it is diamagnetic. Okay. So these are the old considerations. At first, these assumptions were made that the electrons from 4s2 orbital shifts to 3d and the 4s and 4p empty orbitals undergoes hybridization. Okay. But there are some evidences. If we consider this type of hybridization, this type of bonding, then all four carbonyls would be equivalent. बरोबर. सगळे चारही कार्बोनिल्स हे इक्विव्हॅलंट असतील. Then four carbonyls are donating electrons to this nickel atom. So this nickel atom acquires negative charge. निकेल atom वर काय येईल निगेटिव्ह चार्ज येईल चार्ज पार्शियल निगेटिव्ह चार्ज येईल पूर्ण नाही पण निकेल ॲटम इलेक्ट्रॉन्स घ्यायला आणि कार्बन मोनॉक्साईड काय करतायत देतायत मग ह्याच्यावरती निगेटिव्ह चार्ज अकोमलेट झाला पाहिजे सो such thing is not happen because metals cannot acquire negative charge metals are always positive okay then when we study few reactions few substitution reactions etc then it is found that the two carbonyl groups are of different type and two carbonyl groups are of different type okay. Now to explain this the recent orbital diagrams were given. These are the recent orbital diagrams. What it says, previously we have said that the electrons from 4s shifts to 3d. In previous slide we have said that the electron from this 4s orbital shifts to 3d. But recent diagram says that the electrons does not shift. It undergo 4s and 4p. sp3 hybridization. There are 4 sp3 hybrid orbitals. Out of that, 2 hybrid orbitals are empty and 2 hybrid orbital contains one unpaired electron each. Okay. म्हणजे रिसेंट ऑर्बिटल डायग्राम्स काय म्हणतात की sp3 हायब्रिड ऑर्बिटल जे 4 आहेत त्याच्यापैकी 2 ऑर्बिटल्स मध्ये एक एक इलेक्ट्रॉन असतो आणि दुसरे 2 वॅकंट असतात. Now the field orbital of this carbon monoxide overlaps with empty hybrid orbital of nickel. These two. There is dative bond between these two. This carbonyl and this one and these two carbonyl groups are bonded with the nickel by dative bond, coordinate bond. That's why the nickel acquires quite negative charge and this carbon monoxide acquires positive charge shown here in this diagram. Okay. Then, and these are C triple bond O. These two carbonyls are carbon monoxide molecules are C triple bond O. Now remaining two, these are the C double bond O. These are the C double bond O. The valency of carbon is 4 we know. Then the half filled orbital of this carbon overlaps with half filled orbital of this nickel. Okay, so it is covalent bonding. It is not coordinate bonding, it is covalent bonding because each atom is sharing one electron. Okay, so the such type of two bonds are there from this carbonyl and this carbonyl. Now in this the valency of carbon is 3 now these two with oxygen, this one with nickel. Now one valence is remaining, one valence is remaining. Now we know there is two unpaired electrons in 3d orbital. So this pi orbital of carbon, p orbital of this carbon overlaps with d orbital of this nickel. Such type of two pi bonds are there. Such pi bonds are called as d pi p pi bonds. D orbital and p orbital. Normal pi bond forms between p and p orbitals. Okay. So it is quite different. D pi p pi bond. It is called d pi p pi bond. And the difference between previous one and this one is that previous मध्ये all four carbonyls are equivalent, but in this diagram two carbonyls are equivalent. These two are different one and these two are different. Okay. These two are bonded with metal by coordinate bond. These two were bonded with metal by covalent bond and also double bond, pi bond and sigma bond. Okay. So these are different from the previous one. So such type of and one more advantage of this type of structure is that in previous structures all four carbonyls were donating electron to the metal ion and there will be accumulation of extra 4 electrons on the nickel. Okay. 4 electrons, sorry, 4 means 8 electrons. 4 pair of electrons were donated by carbonyl. So 8 electrons will be extra on this nickel. But here these 4 electrons are shared and these 2 are donated. These 4 are donated. So the negative charge which is accumulated on nickel, that is minimized. That negative charge is minimized by the such type of structure. So this is called as recent orbital diagram method. So you have to write the explanations for these structures. Now we will see what are the evidences which supports this structure. Just now I have said some reactions are there which can show that the two carbonyls are different and two carbonyls are different in nickel tetracarbonyl. So when alcoholic solution of nickel tetracarbonyl reacts with O-phenanthrene, orthophenanthrene. This orthophenanthrene is a ligand. This orthophenanthrene is a ligand, bidentate ligand. It gives a ruby red colored compound which has molecular formula as nickel CO2 times phenanthrene. Nickel CO2 times phenanthrene. Means the reagent is same orthophenanthrene. If all four carbonyls are equivalent, then all four should be get replaced by this phenanthrene. But in this reaction, only two carbonyls are getting replaced, whereas two carbonyls are not replaced by that ligand, O-phenanthrene. It indicates the carbonyls which are coordinate bonded to nickel are get replaced. These are the two carbonyls are strongly bonded because these are bonded by a double bond, sigma as well as pi bond. These two are strongly bonded. These two carbonyls. So these two carbon monoxides gets replaced by O-phenanthrene only, whereas two remains as it is. Two does not get replaced. This indicates there are different types of carbonyl groups. Okay. When it reacts with diarine, also confirms presence of two carbonyl groups, C double bond O groups, and two C triple bond O groups. So the nickel tetracarbonyl orbital diagrams recent. If you have asked in exam, then write both recent orbital diagram as well as old orbital diagrams. But this is regarding the structure of nickel tetracarbonyl. Now for your syllabus, only there is structure of Fe2CO9. It is called iron inia carbonyl. It is called iron inia carbonyl, Fe2CO9. It is a polynuclear carbonyl as it contains two metal atoms per molecule. In this metal carbonyl there are two metal atoms, two Fe atoms per molecule. So it is a polydentate. It is a polydentate. Sorry, it is a polynuclear metal carbonyl. Now, according to X-ray diffraction studies and IR spectroscopy studies, there are three bridging carbonyls and six terminal carbonyls. याच्यामध्ये काय तीन ब्रिजिंग कार्बोनिल्स आहेत आणि तीन टर्मिनल कार्बो सहा टर्मिनल कार्बोनिल्स आहेत. ओके. And there is one metal metal bond. There is one metal metal bond. So the structure of this compound iron inia carbonyl can be written as this one: 1, 2, and 3. These are the acting as bridge between two Fe atoms. And 1, 2, 3, 4, 5, 6. These six carbonyls are the terminal carbonyls. These are terminal carbonyls. These three are bridging carbonyls. And the Fe distance is 2.46 angstrom. It is determined by X-ray diffraction and IR spectroscopy studies, etc. Now the orbital diagrams. Its orbital diagrams are quite complicated. The atomic number of iron is what is? The atomic number of iron, I think it is 27.
26.
26. Electronic configuration
4s2 3d6.
4s2 3d6. There are 6 electrons in 3d orbital. Okay. There are 6 electrons in 3d orbital and 2 electrons in 4s orbital. In this structure I have shown this one upper one is for Fe atom and this lower one is for Fe atom. Okay, खालचा हा इथला आणि वरचा दोन्ही Fe atoms इलेक्ट्रॉनिक कॉन्फिगरेशन आहे. Okay. This is dxy, dyz, dx square y square, dxy and dyz. Same for this below Fe atom also. Okay. So there are 6 electrons in 3d orbital. These two are paired and the remaining 4 are unpaired and these are from 4s. So in this complex, Fe atom undergoes D2sp3 hybridization. It undergoes D2sp3 hybridization. In a normal hybridization, what happens? This dx square, y square, and dz square takes parts in hybridization. Normal hybridization मध्ये काय होते? D2sp3, dx square, y square आणि dz square हे दोन hybridization मध्ये भाग घेतात and these dxy, yz and xz these are called as non-bonding orbitals in concept of molecular orbital theory. Okay, but and the geometry of that type of hybridization is octahedral. Geometry is octahedral. But here this dxy and dz square, these two orbitals are taking part in hybridization. dxy and dz square. Okay. In this way, D2sp3 hybridization is there. These two d orbital, one 4s orbital and three 4p orbitals. These are undergoing hybridization, giving 6 hybrid orbitals. These are giving 6 hybrid orbitals, D2sp3 hybrid orbitals. Now, out of these 6 hybrid orbitals, two hybrid orbitals are empty, these two, and 4 is having one unpaired electron each. 4 hybrid orbitals has one unpaired electron each. So these two carbonyls from forming dative bond, coordinate bond with Fe atom. These two we may say and these two. दोन्ही Fe atomला दोन कार्बोनिल काय करतात? डेटिव्ह बॉन्ड फॉर्म करतात. C डबल बॉन्ड O. ओके. जे 4 कार्बोनिल गेले टर्मिनल 6 पैकी 4 कार्बोनिल डेटिव्ह बॉन्डनी अटॅच आहेत मेटलला. Now one carbonyl can form the sigma bond, covalent bond with this Fe atom having one unpaired electron, this one and this is, and this one this is. Now another one empty unpaired electron is there with d orbital that forms pi bond. खालच्या मध्ये दाखवण्यात आलंय ते वर राहिले माझ्याकडून इथून एक पाय बॉन्ड आहे असा. ओके. सो जे 6 टर्मिनल कार्बोनिल आहेत ह्या मॉलिक्यूल मध्ये, out of these 6 terminal carbonyls, 4 terminal carbonyls are of one type, C triple bond O, and 2 terminal carbonyls are of different type, C double bond O. These are bonded to metal by double bond and simple covalent bond. And these 4 terminal carbonyls are bonded to the metal by coordinate bond. Okay. Now these 3 carbonyls are bridging carbonyls. 1, 2, 3. The orbital having one unpaired electron of carbon overlaps with D2sp3 hybrid orbital which has one unpaired electron. Likewise, sharing of electron is there. These 3 are acting as a bridging carbonyls. These 3 carbonyls are acting as a bridging carbonyls. Okay. So in this way we explain the structure. As it undergoes D2sp3 hybridization, the geometry is octahedral. Geometry is octahedral, somewhat distorted octahedral we may say, not perfect octahedral. Okay. Now there is one unpaired electron in dyz orbital of each metal ion, each metal atom. दोन्ही Fe कडे एक unpaired electron आहे dyz orbital मध्ये. So they overlap with each other. dyz orbital of one metal atom overlaps with dyz orbital of another metal atom and form a metal-metal bond, Fe-Fe bond. Such type of bond is formed by the overlapping of d orbital and d orbital. These are pure d orbitals. D orbital and d orbital. So such bond is called as delta bond. Sigma bond by the overlapping of hybrid orbital of or pure orbital. सिग्मा बॉन्ड काय असतो हायब्रिड ऑर्बिटल मधला किंवा प्युअर ऑर्बिटल मधला ओव्हरलॅपिंग मधला दॅट इज कॉल्ड सिग्मा बॉन्ड ओके पाय बॉन्ड साइड वाईज ओव्हरलॅपिंग सिग्मा बॉन्ड मध्ये ऍक्झियल ओव्हरलॅपिंग असते पाय बॉन्ड मध्ये काय असेल साइड वाईज ओव्हरलॅपिंग अँड वन मोर थिंग इज दॅट पाय बॉन्ड इज फॉर्म बाय द प्युअर ॲटॉमिक ऑर्बिटल्स ओनली पाय बॉन्ड हे प्युअर ॲटॉमिक ऑर्बिटल्स फॉर्म करतात हायब्रिड ऑर्बिटल्स पाय बॉन्ड फॉर्म करू शकत नाहीत हायब्रिड ऑर्बिटल्स डू नॉट फॉर्म पाय बॉन्ड बिकॉज their lobes are not similar their lobes are different their lobes are different okay so the pi bond and sigma bond these are common bonds but this bond is formed by the overlapping of d orbital of metal so it is called delta bond in and this is d pi p pi bond this pi bond is d pi p pi bond this bond is delta bond metal metal bond and this is coordinate bond these are simple covalent bonds okay so this is regarding structure of iron Inia carbonyl. Now remaining there are two carbonyls only for your syllabus. There is structure of Fe3CO12. This is the structure of Fe3CO12. There is no there is two metal metal bonds. There are two metal metal bonds in this structure. One, two. Okay. And two carbonyls are acting as bridge two carbonyls are acting as bridge and remaining 10 carbonyls are the terminal carbonyls. For this one only simply you have to draw the structure. जर Fe3CO12 चं स्ट्रक्चर विचारलं तर तुम्हाला फक्त सिम्पली स्ट्रक्चर ड्रॉ करायचंय त्याचं ऑर्बिटल डायग्राम डिस्क्रिप्शन वगैरे द्यायची गरज नाही then this is the structure of CO2 CO8 cobalt octacarbonyl there are two types of structures for this cobalt octacarbonyl. These are interconvertible. These are in resonance with each other. In one, there are two bridging carbonyl groups, and in another isomer, there is no bridging carbonyl groups, but there is cobalt-cobalt bond. And in previous one, there is no cobalt-cobalt bond, but two bridging bonds. Okay. And this is the structure of iron iridium dodecacarbonyl. Iridium dodecacarbonyl. For your syllabus, for only you have to draw the structure. तर तुम्हाला फक्त ह्याचं स्ट्रक्चर ड्रॉ करावं लागणार आहे परीक्षेत विचारलं तर सो इन दिस वे वी कंप्लीट द मेटल कार्बोनिल्स मेटल कार्बोनिल्स आपण हा एक युनिट संपला आपला ह्याच्यामध्ये आपल्याला जास्त डिटेल मध्ये घेता येत नाहीये कारण हे प्रेझेंटेशन आहे आणि जसं आपण ऍक्च्युअल क्लासरूम मध्ये घेतो तेवढं डिटेल मध्ये घेता येत नाहीये तर कोणाला काही अडचण असेल तर विचारा हा विचारा कोणाला काही अडचण असेल तर